This video is about Module 3, Lessons 4, 6, and 7. And we're talking in this video very quickly about an informal argument for the circumference of a circle and the area of a circle. Okay? We're also talking more in depth about that you can describe the solid created by rotating a 2D figure around an axis of symmetry. So if you're rotating something around a line, that line is called the axis of symmetry. Okay, that's a new word for us. Okay, we're also talking about drawing a 2D cross section, that's a new word for us, of a 3D solid. If you cut a 3D solid, you'll get a cross section, and we'll talk about what that means a little bit later. First, this is a review from the other video that you watched, but basically what I'm looking for an informal argument for the formula for the circumference of a circle is based on the definition of pi. Pi is equal to circumference divided by diameter. That's this part. Okay. If you multiply both sides by the diameter, then this cancels with this, and you have circumference is equal to pi times diameter. Okay, keeping in mind that the diameter is equal to 2 times the radius, we get the circumference equals pi times 2r. Okay, and then we typically write terms from simplest to most complicated, and so instead of this order, we tend to prefer the 2 pi r. R is the variable, so it's the most complicated, and so right, circumference is 2 pi r. That's what we're looking for an informal argument for the circumference of a circle. Okay. Number two, this is also covered in the video, but what we're looking for in this notes paper is that circumference is equal to 2 pi r. We just derived that. If you kind of unroll this and put half of it here and half of it there, okay, that's in the video, then this length is pi r. This height is the radius, and so using the area is base times height for our parallelogram. You get pi times r, which is pi r squared. Okay. Keep in mind that a mnemonic for this is cherry pies are delicious, and apple pies are too. Okay, I really struggle with the fact that most people don't know the difference between 2 pi r and pi r squared because both have r's, both have pi, both have the number 2. But this one is a length, and so radius is not being squared. This one is an area, and so radius is being squared. Please don't get those mixed up. Okay, I now want to switch gears and talk about solids of revolution. Here I have a rectangle here on the screen. Okay, it's over here as well. And I can begin to rotate that around. Now you can't see it very well here in the graph, but you can see it over here. You see a rectangle is being rotated around. Now the question is, what kind of solid will that create? If you kind of do it fast, you can kind of see it, or I can click this button. It becomes a cylinder. Okay, if you rotate a rectangle around, you get a cylinder. Okay. We can look at a triangle as well. And so if I rotate this triangle around, you see that? This triangle around. Okay. Rotate this triangle around, what do I get? I get a cone. You rotate it now this center line right here, this line right here is the axis of symmetry. Okay, like x and y axis, because we're thinking about it in 3 dimensions. Symmetry, we talked about symmetry earlier, so it has rotational symmetry around this axis of symmetry. Okay, finally we're hitting a circle. If I have a circle here and I'm rotating it like this, what do you think I'll get? If I rotate it around, then I get a sphere. Okay, let's jump back over here. All right, you don't have this paper, but this is part of the assignment that is for this week. Each of the 2-dimensional figures shown below will be rotated 360 degrees around the respective line. Create a three-dimensional figure. Okay, if you think about this circle right here being rotated around the line, then this point, for example, will go like this. Okay, this point right here will do a similar thing. This circle, this outer edge, will kind of go over here, and this inner will go over here. And what you're creating, I don't know if you can see it very well, but it creates this donut where this line right here is in the middle. Okay, and there's circles here and circle here. Do you see that? Okay, now it's not always the one above the other. This one we did a little bit ago on GeoGebra. Okay, so if I take this point right here and rotate it around, I get a circle. The bottom, rotate that around, and then this side is over here, I get a cylinder. Okay, I want you to think about C and D, what kinds of shapes are created there when you rotate that around. That's part of the assignment for this week. Okay. Then we're going to this page. Okay, and this was printed and given to you before we left school. If you don't have it, you can do this on a piece of notebook paper. Okay, down here it talks to go to Google search GeoGebra solids or 3D shapes, or it's this URL. So I'm going to go there. This is the website you get to, or if you search solids or 3D shapes from GeoGebra, if you click on that, you go here, and this actually has all 8 solids. There's some that are here, some that are here, some that are down here, but it has all the solids that are in this assignment. Okay, I will do the first 2. I will show you first on the in this GeoGebra file, and then I'll go back and I'll draw it. Okay, so here's the first one. It's a rectangular prism. Okay, and you can see I have a rectangular prism. That's what this is. It's a prism that's a rectangle all the way through. So it's all the way through. It's a rectangle. That's why it's a rectangular prism. Okay, the cool thing we can do, well, let me first define this. This darker orange shape is called a cross section. So it's, if you cut it, then you get a cross section. We can look at those cross sections. Okay, I can also tilt these and look at what that looks like. Now, the question in our worksheet asks what shape is created by that cross section. It looks kind of like this. If we look at it from the top, it's a rectangle. Okay, so we get that shape as a rectangle. Okay. The next one that's asked about on the worksheet is a triangular prism. So if I go back here and look at a triangular prism, okay, again, all 8 are on this page. You'll see I have cross sections here that are triangles, not surprising. Oops, let me go back up. Okay, and if I kind of get it to look like the same orientation that one is in our on the worksheet, and then I tilt it like it is in the worksheet, then I have a triangle. Okay, now I'm assuming that this triangular prism, because it's triangles all the way through, this triangular prism is isosceles triangles. That's a pretty common thing to see. And so if we tilt this just right, I think what we get is an isosceles triangle. So what I'm looking for you to draw here is what this cross section looks like, right? And we saw that it was a kind of a long rectangle. Okay, that's it. And this cross section here, what that looks like, we tend to do dotted lines for things we can't see on the outside, but solid for things we can see. This was kind of a slightly taller than equilateral triangle. Okay, so your assignment is to go through the other 6 shapes, look at what those cross sections look like, just play around with it a little bit, and draw a picture of what the cross sections look like for these other 6 shapes. All right, this week we're talking about the formula for the circumference of a circle and area of a circle, where those come from. We're also talking about solids created by rotating a 2D figure around an axis of symmetry. And we're also talking about the 2D cross sections of 3D solids. Thanks for watching.